Vanakkam. Welcome to this video on biomechanics. We have been looking at biomechanics of the knee joint. In the last couple of videos, we looked at the movements made by the knee joint and the muscles that are responsible for generating these movements. In this video, we will take a simple problem involving the knee joint and solve this using a numerical or symbolic method. This is the question. In order to strengthen the quadriceps muscle, a person is doing lower leg flexion extension exercises from a sitting position while wearing a weight boot. Figure A depicts this is figure A. Okay, this is figure A. Figure A depicts the forces acting on the leg, whereas figure B depicts the mechanical model of the leg with necessary parameters to define the geometry of the problem. What are these parameters? W1 is the weight of the lower leg, W0 is the weight of the boot, Fm is the force produced by the quadriceps muscle on the tibia through the patellar tendon and the patellar ligament. Fj is the reaction force that is seen at the tibiofemoral joint. O is the point about which the movement is happening or is the joint center. Capital A is a point on the tibia where the patellar tendon attaches. Capital B is the center of gravity of the lower leg, that is that point. Okay. Capital C is the center of gravity of the weighing boot and the foot, for example, put together. Where is that? Where that center of gravity comes. The question is, find the muscle force Fm and the joint reaction force Fj in terms of the distances A, B, C and theta, beta, W1 and W0. The question is, how do you know theta? Because I know A, B, C somehow. Let us say that using some model or anthropometric measure, I somehow know where B is, where A is, where C is, for example. I know beta because that is the inclination that the leg is making with respect to the horizontal. Maybe I can measure it using some simple technique like an IMU, for example. How do you know theta? That is the question. You actually do not know, not in the specific case that you are discussing, but for the purpose of this problem, let us assume that theta is somehow given. Someone knows theta and they have given you theta, okay? And W1 and W0 you can of course measure, okay, or estimate. W1 you can estimate, W0 you know because that is the weight of the boot. Some variants of this exercise involves, keeping a dumbbell on the ankle and so on and so forth. There are many variants of this exercise. Now, let us write out the knowns, unknowns, the free body diagram for this case. Okay. I am just going to use the existing picture to draw the free body diagram. I am going to use that xy axis. Okay. I am going to use that xy axis. The vertical distance along the y direction between the origin O and the point A is small ay. The horizontal distance is small ax. Okay. For B, that distance is by, and that distance is bx. Of course, I am interested in finding that distance which is cx. Okay. Now, Fm itself will have two components. Okay. Vertical component, which I am going to call as Fmy, and its horizontal component, which I am going to call as Fmx. Likewise, Fj will have two components. Its horizontal component is Fjx, and its vertical component is Fjy, acting in this direction as shown. To find, or the unknowns are Fmx, Fmy, Fjx, Fjy. Essentially, the problem asks for the joint reaction force and the muscle force. So, Fm and Fj are what is asked. We will have to find the individual components and then find the total muscle force and the total joint reaction force. So, essentially we need to find out Fmx, Fmy, Fjx, Fjy. Given the knowns, what are the knowns? What are the knowns? Theta is known. Do not ask me how. Let us assume that theta is known. Okay. Beta is known. This we can measure, of course. This we know. Small a, small b, small c, W1 and W0 are knowns. These are known. Now, what is Fmx? Fmx is the horizontal component of the muscle force Fm. Remember that the leg itself is inclined at an angle of beta to the horizontal, and the muscle force is inclined at the angle of theta to the leg. So, the net angle with respect to the horizontal is actually theta plus beta. Is it not? I hope this is clear. The leg itself is inclined at an angle and the muscle is inclined at an angle to the leg. So, the net angle with respect to the horizontal with which the muscle is acting is theta plus beta. Okay. So, Fmx is Fm cos theta plus beta. Fmy is Fm sin theta plus beta. Do you know Ax and Ay? Well, we can find it. Unlike Fmx and Fmy, Ax and Ay are affected only by the inclination of the leg itself, which is beta. Okay. So, Ax is A cos beta and Ay is A sin beta. Cx is C cos beta, likewise. Now, to solve this, I think it would be convenient to take the moment about the point O here. So, I am just connecting here about that point. Why? Because the joint reaction force Fj is acting along O. So, if I take the moment about that point, then the components of the moment due to this force will disappear because the moment arms are 0. Because there are many unknowns, it will be useful if I take the moment about one of the points for which I know the moment arms or I know the axis is rotating, for example. So, this is very convenient. So, I am going to write sigma m suffix O counterclockwise considered positive is 0. Okay. But before we do that, let us write out the individual forces, their momentums and the sense of the rotation. Okay. What are the forces that act at O, that can cause a moment about O, right, that not necessarily act at O. What are the forces that have a tendency to cause a moment about O? Okay. Fmy can cause a moment, these are forces, momentums, direction. Fmy can cause a moment and its momentum is Ax, and Fmy has a tendency to cause a rotation in the counterclockwise direction. So, positive moment. How do I know this? Because that is the rotation that this force is causing. I know this. Fmx can cause a moment and its momentum is Ay, that has a tendency to cause a clockwise moment. W1 can cause a moment, W1 will cause a moment in the W1 can cause a moment in the clockwise direction. Its momentum is Bx. W0 can also cause a moment and its direction is in the clockwise direction. Its momentum is Cx, is it not? Cx. Now, we have everything to write out our moment equation. So, let us expand our moment equation, which is sigma mo is 0. That is Fmy times Ax minus Fmx times Ay minus W1 Bx minus W0 Cx, the whole thing is 0. Now, let us name these equations as 1, 2, 3, 4, 5. Something that we have forgotten is that Bx is B cos beta, that is equation 6. Now, substitute for Fmx, Fmy, Ax, Ay, Bx and Cx, that is substitute equations 1 to 6 in this equation, which I am going to call as 7, equation 7, and try to simplify. After some algebra, please take a few minutes and do the bookkeeping, because I am going to skip a couple of steps. Okay. You can substitute Fmx, Fmy, Ax, Ay, Bx, Cx, all these 6 into the moment equation and do some adjustments, do some algebra. Okay. After you do that, you will get Fm sin of theta plus beta times A cos beta minus Fm cos of theta plus beta times A sin beta minus W1b cos beta minus W0c cos beta is 0. Am I correct? Yes, this is correct. This is substituting for Fmy, Fmx and so on and so forth. Now, take those terms that have Fm on one side and W's on the other side, okay, such that I can actually find the value of Fm. Now, simplify such that I can find the value of Fm. Fm is cos beta times W1b plus W0c divided by A sin of theta plus beta times cos beta minus cos of theta plus beta times sin beta. This is looking like sin A cos B minus cos A sin B. We know that this is sin of A minus B. Okay. We know that this is sin of A minus B, which is sin A cos B minus cos A sin B. Okay. Using trigonometric identity, sin A minus B is sin A cos B minus cos A sin B. This is the use this identity and simplify. Where do you use this? In the denominator, of course, in the denominator. If you use this in the denominator, you will find Fm as cos beta times W1b plus W0c, the whole thing divided by A sin theta. What is this? Let us remind ourselves of what this is. We have found something, but let us remind ourselves what this is. This is the quadriceps muscle force, or the force produced by the quadriceps muscle to support the leg at an angle of beta from the horizontal. To support the leg at an angle of beta from the horizontal, you need this Fm force. Now, how do I find Fj? Well, I can use sigma Fx equal to 0, the right side going positive. From the previous slide, what are all the forces in the x direction? There are only two forces in the x direction, Fjx and Fmx. W1, W0 are all in the y direction. Okay, so Fjx and Fmx are the only two forces in the x direction. So that would mean of these Fjx is in the positive x direction because we wanted to use that xy direction. not? And Fmx is in the negative x direction. So, that means Fjx minus Fmx is 0, or rather Fjx is Fmx. But what is Fmx? We found from the previous slide. Fmx is Fm cos theta plus beta, is it not? That is, if you find Fm as per this equation 8, you substitute this value of Fm in that equation. So, to find Fjx, you substitute this value of Fm as found in equation 8 and then multiply it by cos of theta plus beta. Okay, that is Fjx. How do I find Fjy? Same, sigma Fy equal to 0, upgoing is considered positive. If I use that, now there are many others, W's will come into the picture, that is okay. That is minus Fjy plus Fmy minus W1 minus W0 is 0. From this I can write Fjy as Fmy minus W1 minus W0. But what is Fmy? That is Fm sin theta plus beta, is it not? How do I know this? From the previous slide, from my previous work. So, find Fm as per equation 8 and substitute in this equation for Fjy. So, you can find the component, the vertical component of the joint reaction force at point 1. So, I know Fmx, Fmy, Fjx and Fjy, I know everything. Now, if I am interested in the total joint reaction force Fj, all I have to do is find the square root of the sum of the squares. And if I want to know the direction at which this reaction force is acting, all I have to do is find the tan inverse of Fjy by Fjx. This is the joint reaction force and the direction at which this is acting. So, we were required to find the Fm or the components of Fm, Fmx, Fmy, Fjx and Fjy. We have found all the things that we were required to find. Fmx, Fmy, Fjx, Fjy are the unknowns, are the things that we wanted to find. Now, we have found all those things. So, little bit of practice, with a little bit of practice you will be in a position to master this. Please be very careful with your bookkeeping. What appears like trivial, the most trivial part of this entire video, you would think is this table that I have made. It's this little table that we have made, that one. That not. It turns out that the correctness of the entire problem depends on this. Why? Because minus, plus, all those things depend on this. So, you need to know where your forces are, what the momentums are, what the direction of the moments are. Once you are clear with this, application of these is a trivial matter. So, please remember this. While you are solving problems, please remember this. So, with this we come to the end of this video. Thank you very much for your attention.